2, what does the rest of that say? Pi r. Y'all seen that before? Okay, so circumference of a circle, and it says solve for r. We call this a formula or a literal equation because it's got more than one variable in it. When it says solve for r, are we going to end up with a number like 8 or 7? No, because it's got more than one variable. So you're still going to have variables in your answer. What does it mean to solve for r? Get the r all by itself. Good. Isolate the variable that we're looking for, which is the r. So what you want to do is get the r all by itself. What's by itself right now? C. C. So I'll give you all just a couple of minutes to see what your strategy would be. What would you do to get that r by itself?
Didn't you just plug the numbers in where the letters are?
No, we don't have any. This, well, we do in the second part, but the first part we want to solve for r. So we want to just get the r by itself. Then the second thing we're going to do is plug in the numbers.
Yes.
On the test, they might have one like this where you do plug in, or they might have one where it just says solve for r, where you just get your, like in our linear equations, when we get the y by itself, you still have an x in there, that kind of thing, where you still have other variables in there. Which variable do I want by itself? R. R. So that's my goal, to get that r equals. Y'all have time to think about it? You ready for me?
Yes.
Okay. This says C equals 2 pi r, and it means 2 times pi times r, correct? We're trying to get what by itself? R. R. These two things are multiplied by r, so what would we do?
Divide.
Divide, good. If something's multiplied by the r, we're going to divide. I'll do it at the same time if that's okay. If I divide this side, what do I have to do to this side?
Divide it.
Okay. What do I want to get rid of?
2
pi. So I'm going to divide by the 2 and the pi. You might want to put it in parentheses. If you're going to use a calculator, you need to do it in parentheses. Doing it by hand, you don't particularly need to. Divide this side by the 2 and the pi also. Because what does that do over here? And what's left? Just my r. And what do I have over here? The c divided by the 2 pi. Okay. And you might want to rewrite it this way, just to make it look neater. Okay, that's what we mean by solving for r. Look familiar? Well, like I said, think about, remember how sometimes we would have x plus 2y equals 3, and if we say solve for y, how we had to subtract the x from both sides and then divide everything by 2. It's the same sort of thing. You're just trying to get one variable by itself. So this one would end up like this. We would probably say 1/2 x plus 3/2, like that. The same kind of thing, but it's with a c and an r. All right, then the second part, it does say find the value for r. That means we are going to find a number, and we're going to plug in. Substitute is the correct word, but we say plug in. And we're going to put, in place of c, what are we going to put? And in place of pi, what are we going to put? Okay. So how would this look? R equals, what goes on top? And what goes on the bottom?
2 times 3.14.
Okay. Now, let's do your order of operation correctly. What you should do, it's like there are parentheses around the numerator and parentheses around the denominator, so do your denominator first. What do you do there? You with me? And then what do we do to finish it? Divide. Okay, divide. And I would use the calculator. What are you dividing?
Comes out to 15.9235.
0.9235. What do you do in your calculators here, y'all? You have calculators? 100
You take 100,
divided by
6.28.
See if y'all get that answer. Okay. And usually with this kind, you will be allowed decimals. They might say round off to 1 decimal place or 2 decimal places, whatever they say. Anybody have a question about rounding off? This is an approximate answer anyway because the 3.14, that's not exactly what pi is. Any questions on that one?
Well, I plugged it back in to make sure it was right, meaning that I substituted that for R. I did 100 equals 2 times 3.14 times 15.94 or whatever, and it didn't work out. It came out to like 99 point something something, so you have to round the 5 and the 3 at the end.
Okay, tell me what you did again now. You're just plugging into this?
Yes, ma'am, I went to the original problem, and I did 100 equals 2 times 3.14 times 15.9235. And it came out to, when I did it in the calculator, 99 point something something, it didn't come out to 100.
Okay, 2 reasons for that. Well, the main reason is this is rounded off. This isn't exact. Pi is not an exact answer. It's irrational. It can't be written as an exact decimal. It can't be written as an exact common fraction. So it will be always when we get our circumference, we're rounding off. If we really use pi, and you do have a pi key, I think, on your calculators, this would carry out many more decimals, and that would affect your answer, but it'd still be approximate, because even what the calculator has is approximate. So yeah, if you get 99.9 or something, that's going to be close enough. All right, number 2. Write the slope-intercept form of the equation of the line passing through the given pair of points. The slope-intercept form of the equation. When I say that, I'm talking about a linear equation. What is a linear equation?
Y equals mx plus b.
Say it.
Y equals mx plus b.
That's the form, and what does it mean? What does a linear equation mean? Its graph is a
Line.
line. Okay, give me that form again.
Y equals mx plus b.
Okay. So when the instructions say write the slope-intercept form of the equation, we want the equation in this form. The only information we know on this line is the 2 points. What are the 2 points we know?
4, -2, and 8, -7.
Can I go straight from this information
You have
to
to find
this
the
form?
slope first.
And what form do I have to use before I go to slope-intercept form? Yes, it's called point slope. Okay, so first we're going to put it in point slope form. And y'all were already ahead of me on that. The point slope is what?
Y1 minus Y2.
This is y minus
Y1
equals
M.
m.
x minus xy.
And when we have this, it's called point slope because your point is x1, y1. And your slope is m. All right, well, I know a point up here, so that part's taken care of. What do I not know? I don't know the m, I don't know the slope. So what am I going to have to do first?
Pick a pair.
Okay, I have 2 pair. I have to find
Oh, the.
rise over run. I have to do the slope. Yes, it is rise over run. It's the change in y over the change in x. This is where I do my cheerleader thing in class. You've got to do the change in y over the change in x, the rise over the run, the vertical change over the horizontal change, or use, somebody told me a second ago, I think the formula. What's the formula? Okay, and this means we've got a point, x1, y1, and a second point, x2, y2, and we're gonna plug them into this formula. Which y do I put first?
Y2.
Which one's y2?
Negative.
It doesn't matter. I can go with a -2, I can go with a -7. You can do it, I'm gonna do it -2, you can do it -7. It doesn't matter, but what goes on top, what has to go on top? The y's. All right, so let's do, if I do the -2 first, what's right here in the formula?
Negative.
A minus, and then minus the other y, not 7, -7. I tell my students, don't leave that step out, because it's minus a -7, which ends up being plus a positive. So don't leave this step out. Since I picked the -2 first, which x do I have to pick first? 4. If you pick the -7 first, you're going to pick the 8 first, and it doesn't make any difference. It's going to come out the same, and it's 4 minus 8. Y'all second. Work that. Tell me what the slope is. Y'all working it? Okay, so up here I would do, does everybody do this? You know what I'm doing there? Everybody all do it? Okay, and if you want to do it here, you can also do that. So what's a -2 and a 7? And what's a 4 and a -8? And do I leave it like that?
No, you have to turn, you have to put that on top.
I move that negative to the top. So did everybody get that, no matter which method they used?
I just kept that changing, changing the powers, positive.
Made a mistake?
No, I just didn't change it, I just went ahead and just subtracted out of my. Yeah.
But you got the same.
The 5
Yeah,
on
you
the
don't have
top
to show that
instead
work.
of-
Yeah,
okay.
no. You don't have to show that work. Did everybody get -5 over 4? No matter which one you used first? It doesn't make any difference. Okay, what was this? This is the M, the slope. What form did I say I had to use? Yes, ma'am. You got 9 over 4? Okay, let's see. You got, let's see. Figure out what we did. You did -7 minus. It's a negative. Yeah. It's a negative. Right here. Okay. So little typo. Yeah, be careful if there's negatives on the test. Make sure you see them so that the negative is also available in different answers. Wait.
5 over 4.
It needs to be a negative. Did you get a positive? What's a -7 and a 2? You should calculate. A -7 plus a 2. Is a negative side. Okay. Anybody else have a problem? There's a calculator problem over there. Make sure if you use your calculator, make sure you enter it right. Oh, I'm sorry. More on.
What do you normally teach?
310 and 320. Okay, so we've got the slope. Back to this. What form did I say I was going to use? Before I get the slope intercept?
Point slope.
Point slope. I can't go straight to this because I do know the slope, but I don't know the y-intercept. I don't have that B. Now, some of your teachers may have taught you a different way, but this is the way our department head wants us to go through all the steps and use the point slope next. Well, I do have the slope. I need a point. Do I have a point? In fact, I have how many? 2. I only need 1. Which one do I use?
1.
Exactly. Good. You don't know the answer. Okay, so I'm going to say y minus, that is always a minus starting out. Which point do y'all want me to use? I'll use this one just because the number's a little smaller. difference. Y minus, what's the Y value here?
-2.
Okay. Again, don't leave this step out because you'll make mistakes if you do. Show this starting off. Equals,
Can you automatically change it to a plus if that's how?
you really won't make a mistake. Yes. If you know it and you're not gonna make a mistake of it, yes. What people tend to do is say, oh, there's already a negative, and then just put one negative. Don't do that. You can
No,
go straight
automatically
to,
put the
that's good, that's fine. Equals, what's my slope? Parentheses, I've had my students make this mistake, they forget about this parentheses right here. What goes right here? And then a minus, and then 4, good. And because I didn't do that right off, what is the first thing I have to do? Make that a plus. Okay. See what y'all can do from there. What's our next step? Are you just gonna multiply? What kind of multiplication do you call that? Okay. Let me see y'all do that. Don't forget this little 4 guy over here. It's got to be multiplied too. Already done it? Okay. So I still have the y plus 2. What happens when I distribute here? Negative 5/4 x. What's a negative times a negative? Positive. Calculators, or do it on scratch paper, or go through all the steps. What are you going to get? You're doing negative 5 over 4 times negative 4 over 1. You cross out the 4s, you can say 20 over 4. You get negative times negative positive, so you do get 5. Everybody get that? Or use calculators if you want. Show the scratch, whatever. Different ways you can come up with the answer. Also, straight to the 5, whichever way. All right, am I finished? What do I need to do? How do I move it since it's a plus here? From both sides, combine like terms. That's why I put it under the 5. Some of you like to do -2 across. Anybody do it that way? That's fine too, whichever way you want to do it. What do I end up with? Y equals? Okay? Anybody not get it? Any typos? Questions? Get it this time.
You didn't make that on basic 5?
Okay.
Last one.
You have a
Negative 5 times 4. It was a -4.
oh,
So 2 negatives when you're multiplying makes it a positive. Okay? All right?
I thought this was gonna be multiple choice.
The review? No. Test. The 320 one is. I didn't do the review. She'll be here today. You can talk to her. Okay. Let's go on to number 3. Perform the indicated operations. What I always warn my students about is number 3 an equation. No. Why is it not an equation? There's no equals. So you're not going to solve. So don't be trying to tell me what y is. You can't do that because all we're doing is combining like terms. Simplifying. And it looks a little complicated. What's the first thing you're going to start with on that one? Good. Everybody see that minus on the second parentheses? You've got to distribute that minus. And in effect, what does that do? Change all the signs. All right.
All the signs from there on out?
No, all the signs of what? In the
second equation.
In the second parentheses, in the second expression. Second parentheses. All right, so let me start writing this one down over here. While y'all are doing that. tell me if I copy it wrong. That's one thing you have to be careful on these tests. You have to do it on the scratch
Two on the
paper.
Y, the two Y, two instead of three.
You have to do it on scratch paper, so you've got to copy your problems down. Make sure you copy them down right. Some of them are very long, and you don't want to start off copying it wrong. This is the minus that we're going to be distributing. Tell me if I do anything else wrong up here. So right now, I don't need to change anything here, do I? Do I really need these parentheses anymore?
No.
No, because there's nothing out here. I can just write it without the parentheses. This one, we're distributing that negative, or some people like to put -1 right there. And what are we going to have when we distribute that? We have good. And then this one was not involved in that minus, so again, I don't need the parentheses, and all these signs stay the way they are. Now, in your book, he shows you rewriting it. Do y'all like to do that, where you group the things that are alike together? You like to do that? You can do that, or you can just go through and mark them out. What he would do in the book, he says, let's put the 2y squared, what would come next?
Minus 6y.
And what would come next?
Plus 4y squared.
Because there's so many of these, I better kind of mark them, make sure I've used them. And then we would put the y's. What do I have? -7, don't forget that negative. And then I've got, and then, okay. Then I go back and take care of all the plane numbers. So I see, okay, did I get them all? And again, in the book, he will show you grouping this, like factoring out the y squared. Is it okay if I just go ahead and add the way they are? Okay, all these are like terms, yes? To be like terms, it's not good enough to just both have a y. They both all have to have y squared when you're adding. Not true when you multiply. A 2 minus a 6. Plus a 4? 0. So 0y squared, you can write that down, or do I need to? No. A -7y, a -6y. Good, use your calculator if you need to, write it down on scratch paper. Everybody with me on that? A -7 minus a 6, same as plus a -6. -13? Yes? No? I'm not through. And then a -13 minus a 2?
-15.
So we have -15 y. And then I've got to take care of my plane numbers. What's a -8 and an 8? Plus 3? 3. And can I combine anything else? No. No. So am I finished? Yes. Yes. And it might, they might have it like that. What else might they do?
Or, yeah, put it backwards.
Would that be the same answer? Any questions on that one? The handout. Okay. On number 1, they rounded that off to 1 decimal place. We didn't do that. This is Mrs. Glover. You done? Okay. You ready to start?
Hi, everyone.
Do you have the third one? Anybody else need to sign?
You want to sign?
Anybody else need to sign the sign-in sheet to get it done?
Yes.
Okay, I'll do it.
Okay, we're starting with problem number 4. Solve the system of equations, and it's actually 2 problems in one. You see the A and the B part, we're going to first solve it by substitution, and then we're going to solve it by graphing. Now you know there are 3 ways to solve systems of equations: substitution, graphing, and do you remember the third way? The elimination method. Okay? So actually on the exam, if you were given a problem, you're going to have multiple choice answers. If you have a preference of one of those 3 ways to work your problems, you can work your problems any of those ways you'd like. Now, graphing sometimes doesn't give you really accurate answers, but it is one method. So let's begin and follow the instructions on this particular one. We're going to solve by substitution first. Now, to substitute means to put something in place of something else. So with the substitution method, what we're going to do is to take one of these equations and solve it for one of the variables. And we're going to use what we get and plug it in or substitute it in the second equation. Now, when I look at these problems, I notice right away that I have positive 1x here. This is a negative 1, here's a 3, and then another negative 1. So the easiest one to work with is this first problem, or this first equation, as far as rearranging and solving for one of my variables. Okay? And since I have the 1x, that's the one that is going to be the easiest to solve for. I'll just add y to both sides, and I have x is equal to, and you can put that y in the front or behind that minus 3. Now typically we like to put it in the front, so it would read y minus 3. X is equal to y minus 3. Everybody agree? Okay, now this is just the very, very beginning of this problem. But what I do now is to take this second equation, and what am I going to do with this information that I just found here?
You're going to plug it in.
Right, instead of x, I'm going to put this in its place. So with the second equation, I have 3 times quantity y minus 3, because all of that is equal to x. So 3 times the quantity y minus 3 minus this y here is equal to negative 5. Okay, everyone agree? Okay. Now with the parentheses, I need to get rid of those. What am I going to do first thing? I'm going to distribute, and that means multiply both by that 3. So I have 3y, and then what? Minus 9. Very good. Okay. And then on the left-hand side, I want to combine those like terms. Which terms are the like terms? Right, the ones that have the variable y in it. So I have 3y and minus y. This is really minus 1y, right? So this plus 3 and this minus 1 will give me how many y's?
2.
Okay. Now I'm going to solve for y, and I'm actually going to get a number this time. If I keep working this, what's the next thing that I need to do? Add 9, because we want to get all of those constants on the opposite side from my y. What is minus 5 and plus 9?
4.
Positive 4. Okay, so now I have 2y's equal to 4, and y will be what? 2. Dividing both sides by 2, you get y is equal to 2. Okay, am I done with the problem? No, I just have the value for y, don't I? So I need to also find the value for x, and I'm going to go back to this equation here where I solve for x and substitute in place of that y the number I just found, and I get x is what? -1. Okay? Now I'm done with it using the substitution method. And what is my answer? How do I write this answer? Right, it's very important to write these in the correct order. And you write them in alphabetical order. So the x value comes first, even though we found it last. When you write your answer in an ordered pair, that number comes first and then minus 3. Okay? Oh, it's 2. Thank you very much. I was looking at this and just picked up the wrong number. Thank you, guys. Okay. All right, so this was the substitution method. It asks us also to solve by graphing. Okay, so let's look at graphing. And we don't have a rectangular coordinate system in here, so I'm going to draw that it may not be real exact. Let's see what we've got again. I have my first equation is x minus y is equal to minus 3, and I'm pretending that I didn't just work this problem and already know the answers. Okay, so I'm starting over. And then the second one, 3x minus y is equal to -5. Now there are several ways that you can graph equations. Okay, you can graph them by finding any 3 points, and by points I mean ordered pairs like we found over here that would make this statement true. We can graph by finding the x and the y intercepts. And then the third method, and the method that I'm going to use, is use the slope-intercept form. Do y'all remember what the slope-intercept form is? Slope-intercept says y is equal to mx plus b. So if you can rearrange your equation, solving it for y, then you can use this b, and where will that point be? On the x-axis or the y-axis? The y-axis. So you would plot that first, and then you would use the slope, which is always the number in front of x when you have it written in this form. And from that point here, I'm going to use the slope. Remember, the slope is a fraction, and you either go up or down, left or right. So that's how I'm going to graph this. Okay, like I said, there are the other methods as well. So with this first equation, I'm going to subtract my x and move it to the other side. And I'm thinking of this, so I'm going to write minus x minus 3 here. Okay, but notice I have minus y, not positive y. So how do I make this into this? Right, so what's it going to do to all of these signs? It's going to change them all. Okay? So I have it in slope-intercept form. Okay, and with this then, what am I going to plot first? The 3, and it's on the y-axis. Okay. And then, well, what's wrong here? I don't have a number in front of this x. It's a 1, right? So the slope here is 1, which is 1 over 1, right? So from here, I'm going to go up 1, over 1. And you can do that several times if you'd like, especially if the points are close together. If you're using graph paper and a ruler, you don't have to worry about it so much. Like I said, I'm freehanding here, y'all, so I'm going to do my best. But this is the first equation. Okay? Now let's look at the second one. 3x minus y is equal to negative 5. Again, I'm going to graph using the slope-intercept form. So I want to rearrange again. Keeping in mind the form that we want our equation in, I'm going to write my x term first on the right-hand side. Okay, and then once again, I have a negative y, but what I need is a positive y. So I will have y is equal to what? 3x plus 5. And don't forget, when you have this actually, along with its sign, you want to not forget that sign, is your y-intercept. And this is your slope. Okay, so on this same graph then, this same coordinate system, I'm going to graph this equation and see what happens. I have a y-intercept of 5, and then I have a slope of 3, which is 3 over 1, and both of those are positive. So I'm going in the positive direction, up 3 over 1, and I have a point there. Now I'm going to draw a line and hope that I get close to my point of intersection here.
You're doing great so far. We like your graph. Y'all are just like, yeah, I didn't have to draw without a grid.
It looks like something like this.
They've seen me with it.
Okay, if you used graph paper, of course we already know what the answer is because we've already worked it here. It should come together at minus 2. No, minus 1, positive 2. I'm really transposing my numbers today, aren't I? So minus 1 and positive 2 is where that should have come together. Okay? And by looking at this graph, you would be able to tell that the intersection is at minus 1 on the x-axis, and then on the y-axis, positive 2. Okay. Anybody have a question?
You have a question about it? Lisa, are you lost on something?
Well, I just didn't get that at all. I don't.
Well, y'all raise your hand because we're here to help.
Yeah, we'll help
At
you.
your desk.
Anybody else not get it? Minus 1, 2.
Oh, I got the minus 1, 2 when we did it the other way, but putting it on the graph, I didn't use the distance. If we can't get it that way because our teacher doesn't teach
That way, can we just make up points for everyone?
Yes. When I started, I said there's different ways you can work the problem. So the other thing that you might be accustomed to seeing is a table like this. And if you find intercepts, which a lot of people like to use intercepts because it's so easy to work with zero, you would even think of it like this. I don't think that was okay, so with the first equation, if you wanted to find the points using intercepts, you remember how to do that? You take this x, put 0 in, and find the y that goes with that x. And this is an ordered pair that would be on your graph. Okay, and then you do the same thing. This time with y0. Okay, and you could plot with those 2 points. You could draw your line. So that's another way to do it. Yes?
Will it always work out with y equals mx plus b to graph it?
Mm-hmm. Yes. Any other questions? Okay. So this is problem number 4, solved first by substitution and then by graphing.
Right, one of the suggestions that we had at the midterm was that there was several people who requested that the review be longer. And so we have the second hour going from 1:30 to 2:30. If you have a 1:30 class, we have keys that you can take with you, but it just has the answer on it. If you're able to stay, obviously that would be the better choice for the second hour. All right, they've got classes. All right. I'm Rose Shirey.
Stay a few more minutes.
And I teach 310, 320 in college algebra for those of you that haven't met me before. And so I'm going to be picking up for the second hour. And so I want you to go ahead and start working on number 5. And notice that it has 2 separate questions. You're going to find the answer by elimination, and then you're going to answer 2 questions. So go ahead and work on number 5. And then in a few minutes, then we'll talk about that.
Anybody need help?
There it is in the fourth document. Yes, there. Okay, now we're going to take this by elimination, not by substitution. Okay, so you need to decide that you're going to eliminate the x but you're heading in the right direction.
Yeah, you have to find the line.
Oh, find the, then you have to put the text.
Put it into the original.
You have to find it. No.
Are you gonna be
I wonder if you will make it. I'm sure you will make it.
All right, we ready to get started on this one? All right, elimination. With the elimination, thank you, Susan. With the elimination method, you're going to either eliminate the x's or eliminate the y's. And notice we chose the hard one, right? I believe in you. You can do this. So you can't just multiply one by something and get the other one. It's not that easy. On this one, we're going to have to multiply both of them. All right, so let's talk about that. When you make that decision about whether you want to eliminate the x's or the y's, how do we make that decision? Well, let's look at the x's. The x's are 5 and 3. So what we need is a number that both of those can go into. Now, what words does that sound like? Sounds a lot like the least common denominator, which you've heard a whole lot about, right? So we're finding the least common multiple, which is a lot like the least common denominator. Remember that they usually do that. I pretend they're fractions. If you were adding 1/5 and 1/3 together, what denominator would you use? 15. That's usually how I think about it when I'm finding the number. So if you want to get rid of the x's, then you need a positive 15x and a negative 15x. You want to create opposites. All right, let's look at the y's. If you want to eliminate the y's, we have 2 and 7. If you were adding 1/2 and 1/7, what would your least common denominator be? 14. So if you want to get rid of the y's, then you would need a positive 14y and a negative. Now you don't have to do both, you have to pick, right? Should we poll? Who wants to get rid of the x's? Who votes for the x's? Nobody? All right, well, I got a few hands. Okay, anybody want to get rid of the y's? I think it was about half and half. I usually go with the smaller number unless it's a real easy thing like multiplying by 10. All right, so that's kind of 6 1/2 dozen the other. Let's pick the y's. If you want to pick the y's, remember we need a positive 14y and a negative 14y. Now these are both negative. It doesn't matter which order you do that in, but one has to be positive, one has to be negative. So since they're both negative, let's go ahead and make the top positive. What do we have to multiply negative 2 by to get positive 14?
Negative 7.
Negative 7. So I'm going to multiply everything on the top row by negative 7. When you do that, what do you get? Negative 35x. A negative times a negative is a
Positive.
and then 2 times negative 7. There you go. All right, now remember, we can't just do one. We have to do both. So the second one, we want to turn that into a negative 14y. All right, it's negative 7. What do you need to multiply negative 7 by to get negative 14?
Positive 2.
Positive 2. So we're going to multiply everything by 2. So distribute, what do we get? 6x minus 14y, and 36 times 2 is? Got a calculator? 36 times 2 is 72. And then when you add those together, which is the whole idea of elimination, those of you taking 320 in the spring, you use the same author, and in 320, he calls this the addition method instead of elimination, which is the same thing. So you add those together, negative 35 and positive 6 leaves us with what? Negative
29.
And then what happens to the y's? That's the elimination method. Creating those opposites, doing whatever it takes to make that happen. 72 minus 14 is what? Remember, when the signs are different, you subtract and take the sign of the larger number. All right, then we divide. So x is what?
Negative 2.
Negative 2. A positive divided by a negative is a negative. All right. Are we done? No. Now on the final, just like the midterm, they're going to only ask you for one of the variables. They're going to say, what is x or what is y? However, as I told my class this morning, my suggestion to you, and from all of us teachers, is the best thing to do is to work it all the way out, circle your answer, and then check it. Don't you want to know if it's right? I mean, it's a final. It's 15% of your grade. Don't you want to know? Right? Because I have a lot of people like, Hail Mary, hoping for the best. Right? If you have an opportunity to figure out if it's right, don't you want to take it? So we're going to go ahead and find y, and then we're going to make sure that we did this right. All right, x is negative 2. Now, when you did substitution, which I assume we did already, right? All right, so when you do substitution, there's a big old box up here that says y equals, right? But when you do elimination, no box. So where do we go and find y?
Plug it in.
You plug
Plug it in where? Either one of the original equations. Which one? Which one do you think is easier? Want to do the top? Okay, you get to pick either one. So let's take negative 2. 5 times negative 2 minus 2y is 2. So 5 times negative 2 is? Minus 2y is 2. This is a simple linear equation. We're just solving that for y. So move that 10 over. Negative 2y, 10 plus 2. Divide by negative 2. And y is?
6.
Negative 6. And then, before you say you're done, what should you do? You should check it. How do you check it? In order to be a solution to a system, it has to work in both of them. So take your answer, this is your x, this is your y, and plug it back in here and here, and make sure that it's true. Before you bubble in that bubble, know for sure that you're going to get the answer right. All right, any questions on elimination? Then let's answer the question. We're not done yet. What does it say on number 5? It says, number 1, solve, and then it says A, decide if the graph of the system is a pair of parallel lines, intersecting lines, or one line. What does this tell you?
We need to find another point.
By this answer, we should be able to answer that question. How many answers do you have? You have 1 point. If you were to graph these 2 lines, like Miss Glover just did, if you were to graph these 2 lines, what would happen? They would cross at -2, -6. There is how many answers? Let's look at the next question. Does the system have one solution, no solution, or infinite solution? How many answers are there? 1. It's 1 point. If you were to graph, if you graph these, they're going to cross in 1 point, and there it is. So let's look back at this. It says, decide if it is parallel, intersecting, or one line, which is lines coincide. So what's the answer to the first question? They intersect. 2 lines intersect. Second question, does the system have one solution, no solution, or infinite solution? One solution. If it was no solution, that was the lines were parallel. They would be false. And if it's infinite solution, that means it is the same line. All right.
What instance would it be no solution or infinite?
Let's look at that. Number 6. Excellent question. Let's talk about what happens when it is special. Do number 6. This one had an answer. He didn't have any issues. Okay, I substitute. You did it with me. You need to also practice the substitution.
It's not just one solution, but
Yes, yes. Okay. The second question is like grafting. So there's different ways of grafting. A lot of people like to solve it so wide because it's so easy to graph. I was going to say, all I need is why is the grafting to get through. And it's going to cross. Okay, you will multiply the top by 2, right? -2. And -2. That'd be a positive. There you go. All right, what happened on this one? Stuff went weird. All right, so it doesn't matter if you want to eliminate the x's or the y's because it's all going to be the same. If you multiply the top by 2, then you get 6x minus 4y is, and when you add those together, what happens? Everything disappears. Now, when everything disappears, do you just give up? No. No. You look at what's left. Is what's left a true statement or a false statement? It's true. This is a true statement. Now, what does being a true statement mean?
that they don't ever cross.
If you have a true statement, that means that it is always true. If you were to graph these two lines, they would be the same line. If you put those into slope-intercept form, you're going to find out they are the same line. So if you get a true statement, the question is, how many answers does that thing have?
Infinite.
A whole bunch, right? So your teacher may have said this in different ways, which are all true. They might have said infinite solutions. They might have said lines coincide. Is there any others that I'm not remembering? Anybody? A whole bunch of them, all right? So every point on the line is also on the other line. So the answer is infinite solution. Now, if we had worked this out, and let's say that this was 10, negative 20 and positive 10, then that is not true.
False.
It is false. What does a false statement mean?
They're parallel.
That means it's not working. All right, so if the lines are parallel, how many places are they going to touch?
No.
The answer is not that they are parallel. Not bad for freehand, right? I draw worse than Ms. Borowski, I promise. Right? If they never touch, then what we're looking for is how many places do they touch? Never. The answer is no solution. And you might write it out in words, or you might use the I'm lazy mathematical symbol, right? Which means no solution. Either way, parallel lines means no solution. They never touch. Okay, any questions on number 6? All right, we're going to totally switch gears here. Go ahead and see if you can get number 7 set up. Word problems.
Always
Life is a word problem. All the time. All the time. Yes.
My brain is scrambled when it comes to this.
Okay, I didn't answer the question, did I? Okay, solve the system by elimination. We solved it. 0 equals 0, right? And it says, is it parallel lines, intersecting lines, or one line? So infinite solution means they are one line. Lines coincide. And then the second question is saying that it is infinite solutions, right? Whenever you decide you're going to do this, you have to do everything. So -7 times 5 is it's okay. And we have to find, in order to create options, we have to find a number that both of those. So we have words about it. From multiple, it's a lot less. So I like to look at the side of that. So if you were going to add 1/5 and 1/3 together, what would you do from that? 15. That's how I got that. On this one, it's a lot easier to memorize. Okay, the opposite of -6 would be +6. So all you have to do to make that happen is multiply it by 2. It's a lot faster than the other one. Okay, you start with defining your variables. Say x is this and y is that. Okay, now create opposites. This is 1f and this is 25f. So you're doing elimination, so you need to create opposites. Do you want to get rid of the x or the b? Your choice. Yep. Yep, you're right. You got it set up, now you just need to solve. Sorry. Give it a minute. You guys have to work on it. right, we ready to go ahead and get started on this one? First of all, how many unknowns do we have? 2. So we're very original in math. If we have 2 unknowns, we call one of them and the other one y. Woo! Right? And if you want to get really original, you could call floor seats F and balcony seats B. Right? So we have 2 unknowns, which means we're going to have a system, just like we've been doing here, right? Now to have a system, that means if you have 2 variables, you have to have 2 equations. All right, so the 2 equations come from, the first one is about quantity, which is how many tickets. The second equation comes from the money. All right, so let's start with the quantity. X is how many floor seats. Y is how many balcony seats. So if you take how many floor seats plus how many balcony seats, what does it say?
508.
How many seats are there?
508.
There you go. That's your first equation. The biggest mistake that happens with this type of problem is people try to mix these 2 up. Keep the money until later, right? Right now it's just how many. The second equation then comes from the money. Now, if you bought 2 floor seats, how much money would you be out? Look at it says the floor seats are
25.
So if you bought 2 of those, you'd be out $50, right? So on the second equation, we're going to have the money from the floor seats plus the money from the balcony seats is the total money that we've earned. Now the money from the floor seats is how many there are, which is what? X times how many they cost. What does it cost? 25. So $25 times how many there are, which is X. If you multiply, let's say you bought 10 tickets. If you multiply how many tickets there are times 25, if you bought 10 tickets, that'd be $250. That's the money from the floor tickets. All right, the balcony ticket. How much is the balcony ticket? That's still expensive for nosebleed section there, right? $18 times how many balcony seats? Y. The money from the floor seats plus the money from the balcony seats says they made how much? A big number.
23.
There we are. I hope somebody has a calculator because I didn't bring one. All right, so that is our system. All right, that is our system. Then we're going to solve by elimination. So we're going to decide, do you want to eliminate the x's or the y's? Your choice. Doesn't matter. All right, if you want to eliminate the x's, then the opposite of a positive 25 would be negative. So we're going to multiply everything on the top by negative 25. When you do that, I'm going to write it over here. We get negative 25x minus 25y. All right, now who's got that calculator?
Negative 12,700.
Thank you. Big number. 12,000 what?
700.
All right, then I'm going to rewrite the second. I'm not changing it at all. I'm just going to rewrite the second equation. Now we have created opposites, which is the whole idea of doing elimination. So what happens to the x's? They're gone. Negative 25y and positive 18y leaves us with what?
7Y.
Negative 12,700 and a positive 11,223. When you have different signs, you subtract and take the sign of the. So this is going to be negative, and somebody tell me what we get here.
1,477.
Negative
Not
1,000.
that big.
Not that big.
How about a small number?
1,000.
12,700 minus 11,223 is negative what?
1,477.
1,477?
Yeah.
Okay, that sounds better. Divide. And first of all, a negative divided by a negative is a?
Positive.
Okay, so 1477 divided by 7 is what? 211? All right, sounds good. Now, what is y in this problem? What does it represent? Balcony seats. So if the question on the final is how many floor seats, then we're not done yet. So how do we find how many floor seats? Plug it back in to either one of the original equations. This one's easier, right? So plug it back in. X plus y. Y is? Subtract. And so x is what?
297.
Now what is x in this problem?
Floor seats.
Floor seats. All right, now be very careful on the final exam because they're not going to ask for both. They're going to either say how many floor seats or how many balcony seats. All right, any questions on number 7? On the word problems, on this review and also the one in your course document, those are representative of the word problems. Every semester, like, okay, if I do all these, then I'm going to be good, right? You need to go back and you need to look at all of the different types of word problems that you did in each of the sections. These are just representative. These are not the ones you're going to see on the final next week. So you're practicing the different kinds. This is a particular type. This is a ticket problem. All right, go ahead and see. You're in Chapter 8, or you finished Chapter 8 now. So theoretically, you should know how to do number 8. Why don't you see if you can do number 8?
I didn't like fall.
I want you to think about the difference between rationalizing this one and rationalizing this one. Doesn't matter.
Doesn't matter.
Nope.
Came up with the same
Yep.
answer.
It doesn't matter. The first thing you do is you make the decision about how you're going to define your variables.
Okay.
So if you decide this is y and this is x, then we're going with that.
As long as we have these numbers down here.
As long as you stay consistent, once you've made that decision, you'll be fine.
Okay, I'll make sure.
Now, either you guys work really fast or you're just waiting for me to do this, which is concerning since you just took test 5. Right? All right, so let's look at this first here. Side trail. You cannot have a radical in the denominator. We got to get rid of that. So how do we get rid of that square root of 5? By itself. So we're going to multiply it by the square root of 5. Now, can you go around just multiplying by the square root of 5 in denominators? Whatever you do on the bottom, you have to do on the top. Because anything over itself is just 1. So we're not actually changing this fraction, right? We're just multiplying it by 1. So let's see what happens. The square root of 5 times the square root of 5 is 5. And if you like, a lot of people get really freaked out about that shortcut. If you would like to write that as the square root of 25, that's okay. Because the square root of 25 is, we're all going to get to the same place. Okay? On the top, we need to distribute. So we have x times the square root of 5 plus 3 times the square root of 5. And I just made that up, so whatever, right? But the point is, if the word is rationalize the denominator. Thank you so much. Rationalize the denominator. What does that mean?
I got wrong.
This is the original problem, and we rationalized the denominator, and we got this. What does that mean?
Right there. Radical.
The radical. You got rid of the radical. Rationalizing the denominator means take care of the issue here. We had a radical in the denominator. We got rid of the radical in the denominator, and it became a nice, fluffy whole number. That's what rationalizing the denominator is. It's a choice. We chose to make the bottom 9. Now notice what happened here, right? When I tell my kids, clean up their rooms, and 2 seconds later they're down the stairs, what just happened?
They threw it all in the closet.
There you go. You're a mom, aren't you?
Yeah.
All right. They threw it all in the closet or shoved it under the bed. Well, what did we do here? We made a choice to clean up the floor, but it had to go somewhere, right? So guess what happened up here? It looks worse than what we started with, right? That is a choice. Rationalizing the denominator, we chose to clean this up, and yep, that's a little worse, right? Shove it in the closet. That's what we chose to do. All right, the second one. If you multiply this by the square root of x, you still got radicals, right? This doesn't work. What's the difference between this and this? Why did it work over here and it won't work over here?
You have to do the conjugate.
There you go.
And do FOIL.
All right, you remember the big fancy word? It is called the conjugate. Now remember back with polynomials, if you multiply x plus 3 times x minus 3, if you do first outer, inner, last, what happens with the outer and the inner? Remember that? I think I heard one person say it. They cancel, right? A plus b times a minus b is A squared minus B squared, the difference of squares, which you did in the factoring chapter. So what we're doing here is we're making that happen. We're making the outer and the inner disappear. Because if you can make that happen, the radical is going to go away. So we do that by the conjugate. Now we used to call that the sum and the difference, right? But he moved across town and he's too good for you now, right? So we don't call him a sum and difference anymore. We now call it the conjugate. So what is the conjugate of the square root of x plus 3?
Square root of x minus 3.
Now, a lot of people confuse this with the opposite. The opposite means you change both of the signs. This is the opposite. This is the opposite. The conjugate, you only change what?
The middle sign.
You only change the middle sign. Remember that it's the same as the sum and difference, right? It's the same thing, we're just not allowed to call it that anymore, right? It was P. Diddy, Puff Daddy, right? Sean, right? It's the same thing, but we're not allowed to call it that anymore. Now it's the conjugate. Okay. Whatever you do on the bottom, you do the same thing on the top. All right, let's do the products. Let's see if this funky thing actually works here. Let's see if that conjugate works. What is the square root of x times the square root of x?
X squared.
The square root of x squared, which is?
X squared.
So in other words, the square root of x times the square root of x is x. A nice, fluffy whole number. The radical is gone. Minus square the last. And if you want to sit there and do FOIL, the outer and the inner are going to? Okay, so if you want to do that, you go for it. All right, the last. Minus 3 times 3 is? 9. Radicals are gone. Right? So that's our magic, multiplying by the conjugate. Do the same thing on top. Now you notice that on top, they're both minus. So the outer and the inner are not going to cancel. Let's write that down. The square root of x minus 3, square root of x minus 3 first, outer, inner, last. All right, we already did this part. The square root of x times the square root of x is x. On the outside, we have negative 3 square roots of x. On the inside, we also have. And then we already did the last, which is 9. But what's different is this right here. What is negative 3 square roots of x plus negative 3 square roots of x? So we have x minus 6 square roots of x plus 9. Notice none of those are like terms. And we're done.
But can't you?
You can only cancel when things are factored. We can't cancel the x and y.
Can't 3 go into all of those?
Not the x.
Separate the radicals and the 3 and the positive 3 and just divide the square roots and.
No, can't do that. No. No. All right, so make sure that you know both of these because they're both going to be on the final. Guaranteed. All right, go ahead and do number 9. Let's see if you remember your factoring.
Yeah.
That's just both of those. Nothing new. No side trails on this one. So if you take a 3x out of here, yes. Look at what's left. Now you bring that square. Look at what's left. Inside. The outside's fine. Leave them alone. Look at what's left on the inside. No, you're right. You're right, but we're not done. Oh. All right, are we ready to factor? Okay, part A. When you are factoring, rule number 1, before you do any other kinds of factoring, you should always look for what? The greatest common factor. If you don't, you're going to bang your head on the wall and chip the paint, right? Always look for the GCF first. So what does this share? What do they have in common? A 3 and an x. So we're going to pull out the GCF, which is 3x, and my suggestion is you physically write this down. When you try to do it in your head, that's where the mistakes happen. If you physically write it down, you see the 3's cancel. X to the third over x. Let's see if you remember your exponent rules. When you divide, you subtract. Well, we got a consensus. Okay. When you divide, you subtract. So 3 minus 1 leaves us with 2 of those guys. Minus 48 divided by 3 is 16, and the x's cancel. All right, now. Are we done? We factored. So are we done? No. Why not? At the top of your final exam, it's going to say in big letters, factor means factor So you're going to say, I factored, and you're going to see x squared minus 16 on there, bubble, right? Wrong. Right? Why is that wrong? Because it's not factored completely. X squared minus cheater over here, right? A squared minus B squared is A plus B, A minus B. So what's the square root of x squared? X. What's the square root of 16? 4. There you go, 4. So this factors to x plus 4, x minus 4. What about this guy? So the answer is all 3 pieces. Factor means factor completely. Any questions on this one?
Yeah, what?
Because the plus and the minus is going to be outer and the inner is going to cancel to get you that result. So that's why it has to be both.
So if we boil that, if we redistribute it and boil.
You will get that. Yes. Check your answers. Multiply it back out. Anybody else? Okay, on part B. 1, 2, 3, 4 terms. If you have 4 terms, what's that? Grouping. All right, so we're going to factor by grouping. Now, it does not always work, the first 2 and the last 2. You're spoiled to that, right? They've totally rigged the problems. It doesn't work that way in real life. However, most of the problems in your book do that. I at least start with that because I call it the good old college try, right? So try the first 2 and the last 2. Let's see what happens. On the first 2, what do they share?
B.
So we're going to pull out a B. And just like I said before, it's a really good idea to physically write that down so that you can see what's left. So when you pull out the B, what's left?
3x minus 4.
All right, now in the second piece, over here we have a negative 15 and a positive 20. So you might think, well, they share a 5, right? If you pull out a 5, you would have negative 3x plus 4. Is that what you need? No. So if you get the opposite of what you need, how can you fix that?
Make it a negative 5.
Instead of pulling out a positive 5, we're going to pull out a negative 5. So if you pull out a negative 5, now we have what we need. Because the whole goal of factoring by grouping is back up here, they didn't share anything. But now, they do. So if they share something, we can factor it out. Just like we pulled out the 3x over here, they share something, we can pull it out. What do they share?
3x minus 4.
So whatever they share, we can pull it out, we can factor it out. And when you pull it out, what's left?
B minus 5.
And you just factored. Woohoo! Now how can you check that?
Plug it back in.
Plug it in.
First, outer, inner, last. Spoil it back out. Make sure you got what you started with. All right, last one, number 10. Work on those. We've got 10 minutes. All right, in the interest of time, I'm going to rush through these here. Those parentheses mean we need to do what? Distribute. All right, so 5, 6 times 6, what happens?
5x.
Plus 5, 6 times 12. 6 goes into 12 2 times. 2 times 5 is? 10. Same thing over here. We're going to multiply. 3 goes into 9. 3 times. 2 times 3 is? And the last one, 2/3 times 3. 3's cancel, leaves you with?
2 plus 5.
All right, what's the next step? Combine like terms. So on the left-hand side, we have 5x plus 11, negative 2, and positive 5. All right, so now it's a normal linear equation. Get your x's together on one side, numbers on the other. It doesn't matter which way you move it. If you subtract 5x from both sides, 6x minus 5x. Subtract 3, so x is?
Yeah.
And remember, you can plug it back in and check it. All right, the second one. The second one is a quadratic. To solve quadratic equations, you have to put it in standard form. This is not in standard form. You have to make this look like this. What does squaring something mean? Multiply it by itself. First outer inner last, we have x squared plus 7x plus
7x
plus
49.
combine like terms. 7x and 7x. Now remember, we have a goal. We're still trying to get this in standard form. Now we're going to be factoring. So if you're going to factor, you want to keep your x squared positive. I call that keeping the boss happy.
I'm sorry, real fast.
Go ahead.
To get the x squared plus the 7x plus 7x plus 49, you fold it.
Yes.
Okay.
Okay, now we're not in standard form yet, but we're almost there. We want to get everything on one side, and we would like to keep the x squared positive because we're going to be factoring. So I'm going to move, and I apologize for doing that in one step. Okay, you could do that in 2 steps. X squared, 14 minus 2, 49 minus 13 is what? 36. Equals 0. Now it is in standard form. Once it's in standard form, then we're going to factor it. X squared plus 12x plus 36. Anybody notice anything fishy about this guy? It's a perfect square trinomial. This is x plus 6 squared. All right, now once you have it factored, we're going to set each piece equal to 0 and solve. But these are the same, right?
Yes.
So the only answer is what? All right, last but not least, 2 minutes. Chapter 8. How do you get rid of a square root?
Square.
The opposite of square root is square. So we're going to square both sides. And if these are inverse operations, what happens? In my class, we say pow pow. Right? They're inverse operations. They knock each other out. So we have x plus 10. Now over here, we are squaring a binomial. And if you say that's x squared plus 4, I have to slap you there. Write that down twice. First, outer, inner, last. X squared minus 2x minus 2x. So when you say it's x squared plus 4, you're leaving out the guts, okay? So this is x squared minus 4x plus 4. And then it's a quadratic. How do you do that? You put it in standard form. So we have x squared minus 5x minus 6 is 0. Factor that. Somebody set the timer on us? No, so need 6 and 1. Set each piece equal to 0 and solve. And don't forget to check it. Plug it back in and make sure that it works. If you plug in the -1, it doesn't work. -1 minus 2 is what? -1 minus 2 is -3. Doesn't work. So the only answer is 6. All right, I have answer keys. I just have the answer on. I'll pass those out. Please turn in your evaluations on the way out. You can just put them up there on the side.